Hello there, and welcome. I'm so glad you're here with me tonight. Whether you've just climbed into bed, or you're settling into your favourite chair, or maybe you're lying down somewhere quiet, I want you to know that this is your time to let go. Let your shoulders drop. Let your breathing slow down. There's nothing you need to do right now except listen, and even that requires no effort at all. Tonight we're going to explore something truly amazing together. We're going to drift through the world of volcanoes. Now, I know what you might be thinking. Volcanoes sound dramatic, don't they? They sound loud and fiery and intense. But here's the beautiful truth. Volcanoes are also ancient storytellers. They're quiet giants that have been shaping our world for billions of years. They've built islands in the middle of endless oceans. They've created the ground beneath your feet. They've warmed the air you breathe and filled the sky with colours you've seen in sunsets. Volcanoes are not just mountains that explode. They're creators, they're artists, they're the Earth's way of breathing. So let your eyes close if they want to. Let your body sink a little deeper into wherever you are. Let the weight of the day fall away. Because right now, in this moment, we're going to travel together. Not through space, but through time. Not through noise, but through wonder. We're going to meet the mountains that breathe fire, and we're going to discover that even in their heat, there is something deeply calming. Something that reminds us we are small, but we're also part of something so much bigger. Are you ready? Then let's begin. Let's drift into the world of volcanoes, where the earth speaks in whispers of smoke and rivers of stone. Fact 1. A volcano is really just an opening in the earth's surface. That's all it is at its simplest. It's a place where melted rock, which we call magma, can escape from deep underground. When that magma reaches the surface and flows out, we call it lava. But beneath that simple description is something extraordinary. Every volcano is a doorway. It's a glimpse into the heart of our planet, a place we can never visit but can only imagine. Deep below where we walk and sleep and live, the earth is hot beyond belief, glowing and moving like a slow ocean made of stone. Fact 2. The word volcano comes from the name Vulcan. Vulcan was the ancient Roman figure associated with fire and metalworking. People in ancient Rome believed that a smoking mountain was the chimney of Vulcan's workshop, where he hammered and shaped metal deep underground. They thought the smoke rising from Mount Etna was proof that he was working down there. It's a beautiful image, isn't it? The idea that every burst of ash and every glow of lava was just someone creating something new. Even though we know now that volcanoes are natural and scientific, there's still something poetic about the idea that mountains are workshops of creation. Fact 3. There are around 1,500 active volcanoes on Earth right now. That number includes all the ones on land that could erupt at any time. But the word active doesn't mean they're all erupting today. It means they've erupted in the last 10,000 years, or they're showing signs they might erupt again. Some of these volcanoes are quiet and patient. They sit still for centuries covered in forests and farms, and then one day they wake up. Others rumble and smoke constantly, like they're always clearing their throat, always reminding us they're alive. Fact 4. Most volcanoes are found along the edges of huge pieces of Earth's outer shell, which we call tectonic plates. Imagine the surface of the Earth like a cracked eggshell. The cracks are where the plates meet, and at those cracks the Earth is restless. Plates push against each other, they pull apart, they slide past one another, and in all that movement magma finds its way up. This is why volcanoes often appear in chains, like a string of islands or a line of mountains. They follow the seams of the earth. Fact 5. The Ring of Fire is the name we give to a massive circle of volcanoes that surrounds the Pacific Ocean. It stretches from the western coasts of North and South America, up through Alaska, across to Japan and the Philippines, and down to New Zealand. This ring is home to about 75% of all the world's active volcanoes. It's also where most of the world's earthquakes happen. The Ring of Fire isn't a single thing. It's a result of many tectonic plates bumping and grinding along the edges of the Pacific. If you were to trace it on a map, you'd see it's not really a perfect ring, but more like a horseshoe of fire and motion. Fact 6. Not all volcanoes are mountains. Some are flat, some are just cracks in the ground. Some are hidden entirely underwater. When we picture a volcano, we often imagine a tall, cone-shaped mountain with smoke coming out of the top. And yes, many volcanoes look like that. But others are wide and gently sloped, spreading out like shields. Some are calderas, which are giant bowl-shaped craters formed when a volcano collapses into itself after a massive eruption. The land itself becomes the volcano. The shape doesn't matter. What matters is that magma can reach the surface. Fact 7. Magma and lava are the same thing, just in different places. When melted rock is still underground, trapped in chambers and tunnels beneath the surface, we call it magma. The moment it breaks through and flows out into the open air, it becomes lava. It's the same glowing, molten stone. The only difference is where it is. Magma is hidden. Lava is exposed, and that exposure changes everything. Lava cools when it meets the air. It hardens. It becomes the new ground, the new rock, the foundation for future life. Fact 8. Lava can be as hot as 1,200 degrees Celsius. That's 2,192 degrees Fahrenheit. At that temperature, rock doesn't just soften, it melts completely. It glows red and orange and sometimes even yellow, like the heart of a fire. If you stood too close, the heat alone would burn you, even without touching it. But from a distance, people who study volcanoes say that watching lava flow is almost hypnotic. It moves slowly, like thick honey, carving paths and creating new land as it cools. There's something about that slow, unstoppable movement that feels almost alive. Fact 9. There are different types of lava, and they behave in different ways. Some lava is thin and runny, flowing fast down the sides of a volcano like a river. This type is called basaltic lava, and it comes from magma that doesn't have much silica in it. Other lava is thick and sticky, moving slowly and sometimes piling up in chunks. This kind has more silica, and it can trap gases inside, which makes eruptions more explosive. The type of lava a volcano produces depends on what's melting underground, how hot it is, and how much pressure is built up. Every volcano has its own personality, shaped by the chemistry of the earth beneath it. Fact 10. When lava cools, it becomes igneous rock. Igneous means born from fire. This is one of the three main types of rock on Earth. If lava cools quickly, like when it flows into the ocean, it becomes smooth, glassy rock like obsidian. If it cools slowly, deep underground before it even reaches the surface, it forms rocks with visible crystals like granite. Either way, every piece of igneous rock started as something molten, something impossibly hot. And now it's solid. Now it's the ground we walk on. It's a reminder that even the hardest, most permanent-seeming things were once fluid and changing. Fact 11. Volcanoes don't erupt randomly. They erupt because of pressure. Deep underground, magma collects in what we call a magma chamber. As more magma pushes up from even deeper in the earth, the chamber fills. Pressure builds. Gases dissolve into the magma, and as the magma rises toward the surface, those gases expand. Eventually, the pressure becomes too much. The magma forces its way through cracks and weak spots in the rock above. That's an eruption. It's not anger. It's not chaos. It's release. It's the earth letting go of something it's been holding. Fact 12. Some eruptions are quiet and gentle. Lava simply oozes out and flows downhill, and people can watch from a safe distance. This happens most often with shield volcanoes, which have thin, runny lava. The eruptions of Kilauea in Hawaii, for example, are often like this. The lava flows steadily, sometimes for months, creating new land as it reaches the ocean. There's no explosion, no ash cloud, just a glowing river of stone, moving at the speed of a slow walk. It's almost peaceful, in its own way. Fact 13. Other eruptions are violent and sudden. When thick, sticky lava traps gases inside, pressure builds up until the volcano explodes. Ash, rock, and gas blast into the sky. These are called explosive eruptions, and they can send debris miles into the atmosphere. The eruption of Mount St. Helens in Washington in 1980 was like this. The entire north side of the mountain blew apart. Ash covered cities hundreds of miles away. The sound was heard in Canada. And yet, even in that destruction, there was creation. New valleys formed. New ecosystems began. The earth was reshaping itself. Fact 14. Volcanic ash is not like the ash from a campfire. It's not soft and fluffy. It's made of tiny, sharp fragments of rock and glass. When a volcano erupts explosively, it shatters magma into millions of pieces, and those pieces are blown into the air. Volcanic ash can travel thousands of miles on the wind. It can bury entire towns. It can damage engines and lungs. But it also has another side. When ash settles and mixes with rain and time, it breaks down into some of the richest soil on Earth. This is why people have always lived near volcanoes, even knowing the danger. The land is fertile. The harvests are abundant. The ash is both destroyer and giver. Fact 15. Pompeii is one of the most famous examples of a volcanic disaster. In the year 79, Mount Vesuvius erupted in Italy, burying the Roman city of Pompeii under many feet of ash and rock. The eruption happened so quickly that people and animals were frozen in place, preserved exactly as they were. For more than 1,000 years, Pompeii was forgotten, hidden underground. Then, in the 1700s, people began to dig. What they found was astonishing. Streets, homes, art, food, and even the shapes of people who had tried to escape. Pompeii became a window into the past, a moment trapped in stone. Fact 16. Mount Vesuvius is still active. It hasn't erupted since 1944, but scientists know it will erupt again. Millions of people live near Vesuvius today, in the modern city of Naples and the towns around it. It's one of the most carefully watched volcanoes in the world. There are sensors on the mountain that detect even the smallest tremors. There are plans for evacuation, but still, people stay. They live their lives in the shadow of the volcano because the land is beautiful and the soil is rich and home is home, even when it sits on the edge of something powerful. Fact 17. The largest volcanic eruption in recorded history happened in 1815, when Mount Tambora in Indonesia exploded. The eruption was so enormous that it sent ash and gas high into the atmosphere, blocking out sunlight all over the world. The year that followed, 1816, became known as the year without a summer. Crops failed. Snow fell in June in parts of Europe and North America. People went hungry. The eruption killed tens of thousands of people directly, and many more died in the famine that followed. And yet, Tambora itself is quiet now. It's a reminder that even the most powerful events eventually settle into silence. Fact 18. Volcanoes release gases when they erupt. The most common gas is water vapor, which is just steam. But they also release carbon dioxide, sulfur dioxide, and other gases. Some of these gases are harmful to breathe. Sulfur dioxide, for example, can mix with water in the atmosphere and fall as acid rain. But over millions of years, volcanic gases have also helped create the atmosphere we breathe today. Early in Earth's history, volcanoes released the water vapor that eventually condensed into oceans. They released the gases that became our air. In a very real way, volcanoes gave us the sky. Fact 19. There are volcanoes under the ocean, and there are far more of them than there are on land. In fact, most volcanic activity on Earth happens underwater, along the mid-ocean ridges. These are long chains of underwater mountains where tectonic plates are pulling apart. Magma rises up to fill the gap, creating new ocean floor. These underwater eruptions are usually hidden from us, happening in the deep, dark parts of the sea. But they're constant. They're always building. The floor of the ocean is being made and remade piece by volcanoes we'll never see. Fact 20. Sometimes, underwater volcanoes grow tall enough to break the surface of the ocean, and when they do, they become islands. The Hawaiian Islands are a perfect example. Each island in the chain was formed by a volcano rising from the ocean floor. Over millions of years, lava piled up, layer after layer, until it reached the sunlight, and then it kept growing. The big island of Hawaii is still growing today, because Kilauea and Mauna Loa are still erupting. Every time lava flows into the sea and cools, the island gets a little bigger. It's creation happening right now, in real time. Fact 21, Mauna Loa is the largest volcano on Earth. If you measure it from its base on the ocean floor to its summit, it's taller than Mount Everest. Mauna Loa rises more than 4,000 meters above sea level, but it extends another 5,000 meters below the water. That's 9,000 meters in total. It's a giant but a gentle one. Mauna Loa is a shield volcano with slopes that rise gradually. Its eruptions are usually calm with lava flowing slowly outward. It last erupted in 2022, and it will erupt again. It's patient, but it's not finished. Fact 22. Volcanic islands are often incredibly beautiful. Because they're formed by lava, the soil is dark and rich. Rainforests grow thick and green. Waterfalls tumble down the sides of old craters. Beaches are sometimes black, made of volcanic sand. These islands are isolated, surrounded by ocean, and because of that they become home to plants and animals found nowhere else on Earth. Life adapts. Life finds a way. And in the shadow of volcanoes, life thrives in ways that are unique and precious. Fact 23. Iceland is a country built almost entirely on volcanic rock. It sits on top of the mid-Atlantic ridge, where the Eurasian and North American tectonic plates are pulling apart. Magma rises constantly. Iceland has over 30 active volcanic systems. It has geysers, hot springs, and lava fields that look like something from another planet. And yet, people have lived there for more than 1,000 years. They've learned to use the heat from the earth to warm their homes and generate electricity. They've turned the power of volcanoes into something useful, something life-giving. Fact 24. The eruption of Eyjafjallajökull in Iceland in 2010 reminded the world how connected we all are. The volcano's name is difficult to pronounce, but its impact was felt everywhere. When it erupted, it sent a massive cloud of ash into the atmosphere. That ash was so thick and widespread that it shut down air travel across Europe for days. Planes couldn't fly because the ash could damage their engines. Millions of people were stranded, and yet in Iceland itself life went on. Farmers moved their animals, towns prepared, people adapted. The eruption was disruptive, but it was also temporary. The ash settled, the skies cleared, and the earth kept turning. Fact 25. Volcanoes teach us something important about time. They remind us that the earth is always changing but slowly. Most of the time, volcanoes are quiet. They sleep for decades, sometimes centuries, but they're never truly gone. They're waiting. And when they wake, they change the landscape. They create new mountains. They bury old ones. They remind us that the ground beneath our feet is not permanent. It's part of a story that's still being written. And in that story, we're just visitors. We're here for a moment, watching the earth breathe. Fact 26. There is a belt of volcanoes that runs through the middle of the Atlantic Ocean, hidden beneath thousands of meters of water. This underwater mountain range is called the Mid-Atlantic Ridge, and it stretches from the Arctic Ocean all the way down to the southern tip of Africa. Along this ridge, two massive tectonic plates are slowly pulling away from each other. As they separate, hot magma rises up from deep inside the earth to fill the gap. This magma cools and hardens, creating new ocean floor. It's happening right now, even as you rest and listen to these words. The ocean floor is being born piece by piece, in a process so slow and so deep that we barely notice it. But over millions of years, this process has shaped the entire Atlantic Ocean. Fact 27. Iceland sits directly on top of the Mid-Atlantic Ridge, which is why the country has so much volcanic activity. But Iceland is also special because it sits over what scientists call a hot spot. A hot spot is a place where a column of extremely hot magma rises from deep within the Earth's mantle, much deeper than the normal sources of magma. This hot spot has been feeding Iceland's volcanoes for millions of years, and because of this, Iceland is one of the few places on Earth where you can see the Mid-Atlantic Ridge above water. You can actually walk between two continents there, standing with 1 foot on the North American plate and 1 foot on the Eurasian plate. The ground is literally splitting apart beneath you, just very, very slowly. Fact 28. Hotspots don't move, but tectonic plates do. This creates something remarkable. As a plate moves over a hotspot, the hotspot punches through and creates a volcano. Then, as the plate continues to move, that volcano gets carried away from the hotspot, and a new volcano forms in its place. Over millions of years, this creates a chain of volcanic islands. The Hawaiian Islands are the perfect example of this. The Big Island, where Kilauea and Mauna Loa are still active, sits directly over the hotspot right now. But the other Hawaiian Islands, like Maui and Oahu, were once over that same hotspot. They've been carried northwest by the movement of the Pacific Plate. Eventually, millions of years from now, the big island will move away too, and a new island will begin to form. Fact 29. There are volcanoes on other planets too. Mars has the largest volcano in our entire solar system. It's called Olympus Mons, and it's absolutely enormous. It rises about 25 kilometers above the surrounding land, which is nearly 3 times taller than Mount Everest. Olympus Mons is a shield volcano just like Mauna Loa, but much, much bigger. Scientists believe it grew so large because Mars doesn't have tectonic plates. On Earth, the movement of plates limits how big a volcano can grow in one spot. But on Mars, the hot spot stayed in one place for millions of years, and the volcano just kept growing and growing. Olympus Mons is probably not active anymore. Mars is a quieter planet now. But it's a reminder that Earth is not the only place where volcanoes have shaped the landscape. Fact 30. Venus is covered in volcanoes. Scientists have identified more than 1,600 major volcanoes on Venus, and there may be millions of smaller ones. Some of these volcanoes might still be active today. Venus is a harsh, hostile world, with thick clouds of sulfuric acid and surface temperatures hot enough to melt lead. But beneath all that, Venus is geologically alive, or at least it was recently. The volcanoes on Venus have created vast plains of hardened lava that cover much of the planet. Looking at Venus is like looking back in time, seeing what a young volcanic Earth might have looked like billions of years ago. Fact 31. One of Jupiter's moons, a small world called Io, is the most volcanically active place in the entire solar system. Io is constantly erupting. Its surface is covered in hundreds of active volcanoes, and plumes of sulfur and gas shoot hundreds of kilometers into space. The reason for all this activity is gravity. Io is caught in a gravitational tug-of-war between Jupiter and 2 of Jupiter's other large moons. This constant pulling and squeezing heats up Io's interior, keeping it molten and restless. Io's surface is painted in yellows, oranges and reds from all the sulfur. It's a violent, beautiful place, and it shows us that volcanic activity isn't just about heat from inside a planet. Sometimes it's about forces pulling from outside. Fact 32. Back here on Earth, there are volcanoes that haven't erupted in thousands of years, and we call them dormant. Dormant means sleeping. These volcanoes show no signs of activity right now. They're quiet. Plants grow on their slopes. Animals make homes there. People might even live nearby without thinking much about it. But dormant doesn't mean dead. It just means waiting. A dormant volcano could wake up again someday. It might take 10 years, or it might take 10,000 years. We don't always know. The Earth keeps its secrets, and a sleeping volcano is one of them. Fact 33. Then there are extinct volcanoes. These are volcanoes that scientists believe will never erupt again. They've been quiet for so long, and the geological conditions that created them have changed so much that there's no magma source left to feed them. Extinct volcanoes slowly erode over time. Wind and rain wear them down. Rivers carve through them. Forests cover them completely. Eventually they stop looking like volcanoes at all. They become just another hill, another mountain, another part of the landscape. But if you know what to look for, you can still see the clues. The shape of the crater, the type of rock, the story written in stone. Fact 34. Edinburgh Castle in Scotland sits on top of an extinct volcano. The volcanic rock, called Castle Rock, formed more than 300 million years ago. Over time, glaciers carved away the softer rock around it, leaving the hard volcanic plug standing tall. People saw that this was a perfect place to build a fortress, high and defensible, and so they did. For more than 1,000 years, there's been a castle on that ancient volcano. It's a place where human history and geological history meet. The volcano is long dead, but it still serves a purpose. It still holds something up. Fact 35. Volcanic rock comes in many colours and textures. Basalt is dark and dense, usually black or dark grey. It forms from lava that cools quickly. Pumice is light and full of holes, so full of air pockets that it can actually float on water. It forms when lava filled with gas cools rapidly. Obsidian is smooth and glassy. black and sharp, formed when lava cools so fast that crystals don't have time to grow. Rhyolite is lighter in colour, often pink or grey, and forms from thicker, more silica-rich lava. Each type of volcanic rock tells a story about how it was made, how hot the lava was, how fast it cooled, and what was in it. Fact 36. People have been using volcanic rock for thousands of years. Obsidian, because it's so sharp, was used to make tools, knives, and arrowheads. Ancient people traded obsidian across great distances because it was so valuable. Pumice is used to scrub and polish, and it's still used today in beauty products and cleaning supplies. Basalt has been used as building stone in many cultures. The ancient Romans used volcanic ash to make concrete that was incredibly strong and long-lasting. Some of their buildings and harbours are still standing today, more than 2,000 years later, because the volcanic ash made the concrete resistant to water and time. Fact 37. Volcanic soil is some of the richest soil on Earth. When volcanic ash and rock break down over time, they release minerals like potassium, phosphorus, and magnesium. These minerals are essential for plant growth. This is why volcanic regions, despite the danger, are often some of the most fertile and productive farming areas in the world. The slopes of Mount Vesuvius in Italy are covered in vineyards. The volcanic islands of Indonesia grow rice, coffee, and spices. The volcanic highlands of Central America produce some of the world's best coffee. Farmers know the risk, but they also know the reward. The land gives back more than it takes. Fact 38. There's a type of eruption called a fissure eruption, where lava doesn't come from a single mountain or crater. Instead, it pours out of a long crack in the ground. These cracks can be several kilometers long. Lava flows out along the entire length of the fissure, sometimes slowly, sometimes in great floods. Fissure eruptions are common in Iceland and Hawaii. They create vast fields of fresh lava, flat and black, that stretch as far as you can see. Walking on a recent lava field is like walking on another world. The ground is sharp and uneven. Nothing grows yet. It's just stone, still warm, still new. Fact 39. In 1783, a fissure eruption in Iceland called Laki changed the world. The eruption lasted for 8 months, and it released an enormous amount of lava and poisonous gas. The gas spread across Europe, creating a haze that blocked the sun. Crops failed. Winters were harsh. Thousands of people died in Iceland, and many more across Europe. Some historians believe that the hardship caused by the Laki eruption contributed to the unrest that led to the French Revolution a few years later. It's a striking example of how a volcano in one part of the world can affect people everywhere. The Earth is connected in ways we don't always see. Fact 40. Geothermal energy is heat from inside the Earth, and volcanic regions are perfect places to harness it. In places like Iceland, New Zealand, and parts of the United States, people drill deep into the ground where volcanic heat is close to the surface. They pump water down into the hot rock, and the water comes back up as steam. That steam is used to turn turbines and generate electricity. It's clean energy, with no burning, no pollution, no carbon emissions. The Earth itself provides the power. In Iceland, almost all of the country's electricity and heating comes from geothermal energy. They've learned to live with their volcanoes not in spite of them, but because of them. Fact 41. Hot springs are another gift from volcanic heat. When water seeps down into the ground and is heated by hot rock or magma, it rises back up to the surface, forming hot springs. These springs are found in volcanic areas all over the world. People have been bathing in hot springs for thousands of years. The warm water is relaxing, and many hot springs contain dissolved minerals that people believe have healing properties. In Japan, hot spring baths are called onsen, and they're an important part of the culture. In Iceland, the Blue Lagoon is a geothermal spa where people soak in warm, mineral-rich water surrounded by black lava fields. It's a place where you can feel the heat of the earth beneath you, warming you from below. Fact 42. Geysers are even more dramatic than hot springs. A geyser is a hot spring that erupts periodically, shooting water and steam high into the air. Geysers are rare because they require a very specific combination of conditions. There must be heat from magma below, a supply of water, and a particular kind of plumbing system in the rock that allows pressure to build up. When the pressure gets high enough, the water explodes upward in a column of steam and spray. Old Faithful in Yellowstone National Park is probably the most famous geyser in the world. It erupts roughly every 90 minutes, sending water more than 30 meters into the air. People gather to watch it, this reliable reminder that the earth beneath Yellowstone is alive and restless. Fact 43. Yellowstone is not just a park, it's a supervolcano. A supervolcano is a volcano capable of producing an eruption more than 1,000 times larger than the eruption of Mount St. Helens. Yellowstone has erupted 3 times in the past 2 million years. The last eruption was about 640,000 years ago. When it erupted, it emptied a huge magma chamber beneath the surface, and the ground collapsed, forming a massive crater called a caldera. That caldera is about 70 kilometers across. Today, the entire Yellowstone area sits inside this ancient caldera. The hot springs, geysers, and bubbling mud pots are all signs that there's still a huge reservoir of magma beneath the park. Yellowstone will erupt again someday, but probably not for many thousands of years. Fact 44. Supervolcanoes are rare, but when they erupt, the effects are global. The ash and gas from a supervolcano eruption can spread across entire continents. It can block sunlight for years, causing temperatures to drop and disrupting weather patterns around the world. Crops fail. Ecosystems collapse. It's what scientists call a volcanic winter. The last supervolcano eruption was Toba in Indonesia, about 74,000 years ago. Some scientists believe that eruption nearly wiped out the human species. The global population dropped dramatically. Only a few thousand humans may have survived. It's a sobering reminder of how powerful the Earth can be and how fragile we are in comparison. Fact 45. But supervolcanoes are not something we need to fear right now. They erupt on timescales of hundreds of thousands of years. The chances of one erupting in our lifetime, or even in the lifetime of our great-great-grandchildren, are extraordinarily small. Scientists monitor places like Yellowstone very carefully. They measure ground movement, earthquake activity, and gas emissions. If there were any signs that an eruption was coming, we would know long in advance. The Earth gives warnings, it trembles, it swells, it leaks gases. We would have time to prepare. And for now, Yellowstone is simply a beautiful, geologically active place where the Earth shows off a little. Fact 46. Volcanoes can create lightning. During explosive eruptions, ash particles collide with each other in the eruption column. These collisions create static electricity, just like rubbing a balloon on your hair. When enough charge builds up, it discharges as lightning. Volcanic lightning is stunning to see. Bright bolts of electricity flash through the dark ash cloud, illuminating it from within. Photographers travel from all over the world to capture images of volcanic lightning. It's a reminder that eruptions are not just about fire and rock. They're about energy in all its forms: electrical, thermal, kinetic. The Earth unleashing power in ways that are both terrifying and beautiful. Fact 47. Volcanic eruptions can also trigger tsunamis. If a volcano erupts near or under the ocean, it can displace huge amounts of water. The eruption of Krakatoa in Indonesia in 1883 created tsunamis that killed tens of thousands of people on nearby islands. The waves were more than 30 meters tall in some places. The sound of the eruption was so loud that it was heard thousands of kilometers away, and it's considered one of the loudest sounds ever recorded in human history. Krakatoa itself was almost completely destroyed in the eruption. The island collapsed into the sea, but in the decades since, a new volcano has grown in the same spot. It's called Anak Krakatoa, which means child of Krakatoa. The Earth rebuilds what it destroys. Fact 48. Not all volcanic eruptions are destructive to life. In fact, without volcanoes, life on Earth might not exist at all. Billions of years ago, when the Earth was young, volcanoes released the gases that formed our atmosphere. They released water vapor that condensed into the oceans. They brought carbon, nitrogen, and other essential elements to the surface. Over time, these elements became the building blocks of life. Volcanoes also continue to play a role in regulating Earth's climate. They release carbon dioxide, which is a greenhouse gas, but they also release sulfur dioxide, which can cool the planet by reflecting sunlight. Volcanoes are part of the balance. They give and they take. They destroy and they create. Fact 49. There are underwater volcanic vents called hydrothermal vents, and they support entire ecosystems in the deep ocean. These vents form along mid-ocean ridges, where magma heats seawater that seeps into cracks in the ocean floor. The water gets superheated, sometimes to temperatures above 300 degrees Celsius, and it shoots back up through the vents. The water is filled with minerals and chemicals from the rocks below. Around these vents, in total darkness, under crushing pressure, life thrives. There are bacteria that feed on the chemicals in the water. There are tube worms, clams, and shrimp that live nowhere else on Earth. These creatures don't rely on sunlight. They rely on the heat and chemistry of the Earth itself. It's life powered by volcanoes. Fact 50. Some scientists believe that life on Earth may have begun near hydrothermal vents. The conditions there, with heat, water, and a rich supply of chemicals, could have been perfect for the first simple organisms to form. It's just a theory, but it's a compelling one. If it's true, then volcanoes didn't just shape the surface of the Earth. They sparked life itself. And in a way, that makes every living thing, including you, a distant child of volcanic fire. You are made of elements that were forged in stars and delivered to Earth by volcanic processes. You're part of the same story. The same flow of energy and matter that builds mountains and erupts in fire also flows through you. Fact 51. There are places on Earth where you can see brand new land being created right before your eyes. In 1963, a volcanic eruption began on the ocean floor near Iceland. The eruption continued for several years, and slowly a new island emerged from the sea. This island was named Surtsey, and it became a natural laboratory for scientists. They watched as waves carried seeds to the barren rock. They observed as birds began to visit and leave droppings that fertilized the soil. They documented the first plants taking root in the volcanic ash. Within just a few decades, Surtsey transformed from a lifeless pile of lava into a living ecosystem. Mosses grew first, then grasses, then shrubs. Insects arrived. Seabirds built nests. It was like watching the story of a life itself unfold in fast forward. Surtsey is now protected, and only a handful of scientists are allowed to visit each year. They continue to study how life colonizes new land, how ecosystems develop from nothing, and how volcanic islands become homes for countless species. Fact 52. The Pacific Ocean is slowly shrinking, and volcanic activity is one reason why. All around the edges of the Pacific, tectonic plates are being pushed down into the Earth in a process called subduction. When one plate slides beneath another, it gets forced down into the hot mantle below. As it descends, the plate begins to melt, and that melted rock becomes magma. This magma rises and feeds the volcanoes of the Ring of Fire. Meanwhile, the Atlantic Ocean is growing wider. The mid-Atlantic ridge is constantly creating new ocean floor, pushing the Americas away from Europe and Africa. This process happens very slowly, just a few centimeters per year, about as fast as your fingernails grow. But over millions of years, these small movements add up. Continents drift. Oceans open and close. Mountains rise and fall. The Earth is in constant motion, and volcanoes are the visible proof of that motion. They're like pressure valves, releasing the heat and energy that builds up as the planet's plates shift and grind against each other. Fact 53. Mount Fuji in Japan is one of the most iconic volcanoes in the world. Its symmetrical cone shape has inspired artists, poets, and travelers for centuries. Mount Fuji is considered sacred in Japanese culture, and thousands of people climb it every year during the summer months. The climb takes most people between 5 and 7 hours to reach the summit, and many climbers start at night so they can watch the sunrise from the top. Mount Fuji last erupted in 1707, during what's known as the Hoi eruption. Ash from that eruption fell on the city of Edo, which is now Tokyo, covering the streets and rooftops. Since then, Mount Fuji has been quiet, but it's not extinct. It's classified as an active volcano, and scientists monitor it closely because millions of people live within range of a potential eruption. The volcano sits at the intersection of 3 tectonic plates, which makes the area particularly unstable. Despite the danger, or perhaps because of it, Mount Fuji remains a symbol of beauty and power. It reminds people that nature is both gentle and fierce, and that we live our lives in the presence of forces much larger than ourselves. Fact 54. Volcanic eruptions have influenced human history in surprising ways. In 1815, when Mount Tambora erupted, The ash and sulfur it released into the atmosphere caused global temperatures to drop. The following year, 1816, became known as the year without a summer. In Europe and North America, snow fell in June, and frost killed crops in July and August. Harvests failed, and food became scarce. People went hungry, and many migrated in search of better conditions. But something unexpected came from this dark time. That cold, dreary summer of 1816, a group of writers gathered at a villa in Switzerland. Among them was a young woman named Mary Shelley. Stuck indoors because of the gloomy weather, the group decided to pass the time by writing ghost stories. It was during this period that Mary Shelley conceived the idea for her novel Frankenstein. A volcanic eruption halfway around the world led to a summer of darkness, which led to one of the most famous works of literature ever written. It's a strange connection, but it shows how the Earth's geological events can ripple through human culture in ways we never expect. Fact 55. Volcanoes don't just exist on the surface. There are volcanic features deep underground that never reach the open air. These are called intrusions. When magma pushes up through cracks in the Earth's crust but doesn't break through to the surface, it cools and hardens underground. Over millions of years, the rock above it can erode away, and eventually these underground formations become exposed. One famous example is Devil's Tower in Wyoming. It's a massive column of volcanic rock that rises more than 300 meters above the surrounding land. Scientists believe it formed when magma cooled inside a volcano, and over time, the softer outer layers of the volcano eroded, leaving only the hard core standing. Devil's Tower is sacred to several Native American tribes, and it's also a popular destination for rock climbers. It's a reminder that not all volcanic activity is dramatic and explosive. Sometimes the most impressive volcanic features are the ones that were hidden for millions of years, waiting patiently to be revealed. Fact 56. There are volcanic formations called lava tubes, and they're like tunnels carved by flowing lava. When lava flows down the side of a volcano, the surface of the flow cools and hardens while the inside stays hot and liquid. The liquid lava drains away, leaving behind a hollow tube. Some lava tubes are small, just big enough to crawl through. Others are enormous, large enough to drive a bus through. In Hawaii, there are lava tubes that stretch for many kilometers. Some have skylights, places where the roof has collapsed and sunlight streams in, creating an otherworldly scene. Moss and ferns grow in these skylights, and the contrast between the dark, rocky tunnel and the bright green plants is striking. People explore lava tubes with flashlights, walking through passages that once carried rivers of molten rock. It's a way to step inside a volcano, to see the pathways that lava carved, and to feel the presence of that ancient heat, even though the rocks are now cool to the touch. Fact 57. Volcanic islands often become havens for unique species because they're so isolated. When a volcanic island first rises from the ocean, it's completely barren. There's no soil, no plants, no animals. But over time, life finds a way to reach these islands. Seeds are carried by wind or by ocean currents. Birds fly across the water and bring seeds in their feathers or their stomachs. Insects are blown by storms. Once life arrives, it begins to adapt to the new environment. Because the island is isolated, the species that live there evolve separately from their relatives on the mainland. Over thousands or millions of years, they become distinct. The Galapagos Islands are a perfect example. These volcanic islands are home to species found nowhere else on Earth, like the giant tortoises and marine iguanas. Charles Darwin visited the Galapagos in the 1830s, and what he observed there helped him develop his theory of evolution. The islands showed him how species change over time in response to their environment, and all of it started with volcanoes rising from the sea. Fact 58. Not all lava flows slowly. In some eruptions, lava can move surprisingly fast. When lava is very hot and has low viscosity, meaning it's thin and runny, it can flow at speeds of more than 10 kilometers per hour. That might not sound fast compared to a car, but it's fast enough that people have to run to get out of its way. In Hawaii, there have been cases where lava flows destroyed homes and roads, advancing steadily over days and weeks. People watch as the glowing orange river creeps closer, knowing there's nothing they can do to stop it. The lava is relentless. It burns everything in its path. Trees burst into flames before the lava even touches them, just from the heat radiating off it. Houses collapse and are swallowed. Roads buckle and disappear under the layers of fresh rock. And yet, there's a strange acceptance in these communities. People know they live on an active volcano. They know the land is temporary. When the lava finally stops and cools, it becomes new ground. And in time, plants will grow again. Life will return. The cycle continues. Fact 59. Some volcanic eruptions produce what's called a pyroclastic flow, and it's one of the deadliest volcanic phenomena. A pyroclastic flow is a fast-moving current of hot gas, ash and rock fragments that rushes down the sides of a volcano during an explosive eruption. These flows can reach temperatures of more than 700 degrees Celsius, and they move at speeds of more than 100 kilometers per hour. Nothing in their path survives. Trees are knocked flat. Buildings are obliterated. Anyone caught in a pyroclastic flow has no chance of escape. The flow is so hot that it incinerates everything instantly. The eruption of Mount Pelee in Martinique in 1902 produced a pyroclastic flow that swept through the town of Saint-Pierre, killing nearly 30,000 people in minutes. Only a handful of people survived, and one of them was a prisoner who was protected by the thick walls of his underground cell. Pyroclastic flows are a reminder that when a volcano erupts explosively, the danger isn't just the lava. It's the superheated gas and debris that can race down the mountain faster than anyone can run. Fact 60. Volcanoes can affect the weather, not just locally but globally. When a large volcanic eruption sends ash and sulfur dioxide high into the stratosphere, those particles can stay in the atmosphere for months or even years. They reflect sunlight back into space, which cools the Earth's surface. This is called volcanic winter. The eruption of Mount Pinatubo in the Philippines in 1991 was one of the largest eruptions of the 20th century. It sent millions of tons of sulfur dioxide into the atmosphere, and global temperatures dropped by about 0.5 degree Celsius over the next couple of years. That might not sound like much, but it was enough to affect weather patterns around the world. Some regions had cooler summers, others had unusual rainfall. Scientists studied the eruption carefully because it gave them a natural experiment in how particles in the atmosphere can influence climate. Interestingly, some researchers have even suggested that we could use a similar method to combat climate change by deliberately injecting particles into the atmosphere to cool the planet. It's a controversial idea, but it's inspired by what volcanoes do naturally. Fact 61. There's a type of volcano called a stratovolcano, and these are the classic cone-shaped mountains most people picture when they think of volcanoes. Stratovolcanoes are built up over many eruptions, with layers of lava, ash and rock stacking on top of each other. Each eruption adds another layer, and over thousands of years the volcano grows taller and steeper. Mount Fuji, Mount St. Helens, and Mount Vesuvius are all stratovolcanoes. These volcanoes tend to have explosive eruptions because the magma inside them is thick and traps gases. The buildup of pressure can be immense, and when the volcano finally erupts, it can be violent. But between eruptions, stratovolcanoes can be quiet for decades or centuries. Snow covers their peaks, forests grow on their slopes, people build towns in the valleys below. The volcano becomes part of the landscape, part of daily life. And then, one day it wakes up. The ground shakes, steam rises from the crater, and everyone is reminded that the mountain is not just a mountain. It's alive. Fact 62. Shield volcanoes are different from stratovolcanoes. They're wide and gently sloped, like a warrior's shield lying on the ground, which is how they got their name. Shield volcanoes form from eruptions of thin, runny lava that spreads out in all directions. Because the lava flows easily, it doesn't pile up into a steep cone. Instead, it creates a broad, dome-shaped mountain. Shield volcanoes tend to have gentle, non-explosive eruptions. The lava flows steadily, sometimes for months or years, slowly building the volcano layer by layer. Mauna Loa and Kilauea in Hawaii are shield volcanoes, and they're among the largest volcanoes on Earth. Their eruptions are relatively safe to observe from a distance, and scientists have learned an enormous amount about volcanic processes by studying them. People even live on the slopes of these volcanoes, farming the rich soil and living alongside the lava flows. It's a relationship built on respect and understanding. The volcano gives, and sometimes it takes, but it's always present. always part of life. Fact 63. Cinder cone volcanoes are the smallest and simplest type of volcano. They form when blobs of lava are ejected into the air during an eruption. As the lava flies through the air, it cools and hardens into fragments called cinders or scoria. These cinders fall back down around the vent, piling up into a cone-shaped hill. Cinder cones usually only erupt once, and they tend to be short-lived. They can form very quickly, sometimes in just a few weeks or months. Paracutin in Mexico is a famous example. It began as a crack in a farmer's field in 1943. Within a year, it had grown into a cinder cone more than 300 meters tall. The eruption continued for 9 years, and when it finally stopped, Paracutin became dormant. The village that once stood there was buried under lava and ash, and now the cone stands as a monument to the power and speed of volcanic creation. You can hike up Paracutin today and look down into the crater, and it's a humbling experience to know that this entire mountain didn't exist within living memory. Fact 64. Volcanic craters are the bowl-shaped depressions at the top of a volcano formed when material is blasted out during an eruption, or when the ground collapses. Some craters are small, just a few meters across. Others are enormous, stretching for kilometers. Over time, many volcanic craters fill with water and become lakes. These crater lakes can be stunningly beautiful, with deep blue or green water surrounded by steep volcanic walls. Crater Lake in Oregon is one of the most famous. It formed about 7,700 years ago when a massive eruption caused the top of a volcano to collapse, creating a caldera. Over centuries, rain and snowmelt filled the caldera, creating a lake that's nearly 600 meters deep, one of the deepest lakes in the world. The water is incredibly clear because there are no rivers or streams flowing into it. It's fed entirely by precipitation, which means there's no sediment to cloud the water. Crater Lake is a place of stillness and reflection, a place where the violence of the past has been transformed into something peaceful and serene. Fact 65. Sometimes volcanic eruptions create what are called volcanic bombs. These are chunks of molten or semi-molten rock that are thrown into the air during an explosive eruption. As they fly through the air, they cool and harden, often taking on distinctive shapes. Some are round and smooth like cannonballs. Others are twisted or streamlined, shaped by their flight through the air. Volcanic bombs can be as small as a fist or as large as a car, and they can travel several kilometers from the vent. When they land, they can smash through roofs, crush vehicles, or create deep craters in the ground. Despite the danger, volcanic bombs are also fascinating objects. Each one is a snapshot of a moment in the eruption, a piece of the volcano frozen in time. Scientists study them to learn about the conditions inside the volcano during the eruption, and collectors sometimes seek them out as unique natural artifacts. Fact 66. There's a volcano in Tanzania called Oldoinyo Lengai, and it's the only volcano in the world that erupts a strange type of lava called carbonatite lava. Most lava is made of silicate minerals, but carbonatite lava is made of carbonate minerals, similar to the minerals in limestone. This lava is much cooler than normal lava, only about 500 to 600 degrees Celsius, instead of over 1,000. When carbonatite lava erupts, it's black, but within hours of being exposed to air it turns white as it reacts with moisture. The result is a volcano that looks like it's covered in snow, even though it's in the middle of the hot African Rift Valley. Oldoinyo Lengai is considered sacred by the Maasai people who live nearby. The name means mountain of the divine in the Maasai language. The volcano is active and erupts frequently, sending up fountains of this strange dark lava that glows faintly in the night. It's a reminder that even after studying volcanoes for centuries, the Earth still has surprises to offer, still has mysteries that challenge our understanding. Fact 67. Volcanic eruptions can create new minerals that don't exist anywhere else. When lava cools rapidly, or when gases interact with the surrounding rock, unique chemical conditions can form minerals that are rare or even unknown outside of volcanic environments. Some of these minerals are prized by collectors for their beauty and rarity. Others are studied by scientists to understand the conditions inside volcanoes. For example, the mineral peridot, a green gemstone, is often found in volcanic rock. It forms deep in the Earth's mantle and is brought to the surface by volcanic eruptions. In Hawaii, there are beaches where tiny grains of peridot mix with the sand, creating a subtle green shimmer. These are sometimes called olivine beaches, named after the mineral family that peridot belongs to. Walking on one of these beaches is like walking on fragments of the Earth's deep interior, on pieces of the mantle that have travelled upward through fire and pressure to rest gently on the shore. Fact 68. The study of volcanoes is called volcanology, and the people who study them are volcanologists. It's a challenging and sometimes dangerous profession. Volcanologists travel to active volcanoes to measure gas emissions, collect rock samples, monitor seismic activity, and study lava flows. They wear protective gear, including heat-resistant suits and gas masks, and they work in conditions that would be unthinkable for most people. They stand at the edges of craters, looking down into lakes of molten lava. They hike across fresh lava fields where the ground is still warm. They set up instruments on the slopes of volcanoes that could erupt at any moment. But despite the danger, volcanologists are driven by curiosity and a desire to understand how the Earth works. Their work helps protect communities that live near volcanoes. By monitoring the warning signs of an eruption, they can help predict when a volcano might become active and give people time to evacuate. Volcanology saves lives, and it also deepens our appreciation for the dynamic, ever-changing planet we call home. Fact 69. There's a volcanic system in Ethiopia called the Danakil Depression, and it's one of the most extreme and alien-looking places on Earth. The Danakil Depression sits at the junction of three tectonic plates that are slowly pulling apart, and the area is incredibly active. There are lava lakes that glow day and night. There are fields of sulfur that shine, bright yellow and orange. There are hot springs that bubble with acidic water in shades of green, red and orange, coloured by minerals and microorganisms. The air is heavy with the smell of sulfur, and the heat is intense, often exceeding 50 degrees Celsius. The Danakil Depression is one of the hottest places on Earth, and it's also one of the lowest, sitting more than 100 metres below sea level. Despite the harsh conditions, people live and work in the Danakil Depression. Salt miners extract salt from ancient dried lake beds, just as their ancestors have done for centuries. The salt is cut into blocks and loaded onto camels, then transported across the desert to markets. It's a harsh life, but it's sustained by the geology of the place, by the same volcanic forces that created this strange and beautiful landscape. Fact 70. Volcanoes can create their own weather. During an eruption, the heat from the lava and the ash cloud can cause moisture in the air to condense rapidly, forming clouds and even triggering rainstorms right above the volcano. These are sometimes called volcanic thunderstorms, and they add another layer of drama to an already spectacular event. The rain that falls during a volcanic eruption can mix with the ash to create a thick, cement-like substance called lahars. Lahars are essentially rivers of mud and debris that flow down the sides of the volcano, and they can be just as deadly as the lava itself. Lahars can travel at high speeds, sweeping away everything in their path, including trees, buildings, and vehicles. They can flow for tens of kilometers, far beyond the reach of the lava. After the eruption of Mount Pinatubo in 1991, lahars continued to be a hazard for years. Every time it rained heavily, water would mix with the loose ash on the volcano's slopes, creating new mud flows. Communities had to be constantly vigilant, and extensive systems of dams and channels were built to try to control the lahars and protect the towns below. Fact 71. There are volcanoes in the deep ocean that we're only beginning to discover. The ocean floor is one of the least explored places on Earth, and scientists estimate that there could be more than 1 million underwater volcanoes, most of them small and inactive, but some are large and very much active. These underwater volcanoes, or seamounts, form along the mid-ocean ridges and at hotspots beneath the ocean. When they erupt, the lava cools rapidly in contact with the cold seawater, forming rounded shapes called pillow lava. The eruptions can also create underwater clouds of particles and heated water called megaplumes. These megaplumes can be hundreds of meters tall and carry heat, minerals, and nutrients up into the water column. They affect ocean currents and provide food for marine life. Exploring these underwater volcanoes requires sophisticated technology, including remotely operated vehicles and deep-sea submersibles. Every expedition reveals new discoveries, new species living around hydrothermal vents, new insights into how the ocean floor is created, and how the planet's geology works beneath the waves. Fact 72. Volcanic eruptions have inspired countless myths and stories throughout human history. Before people understood the science of plate tectonics and magma chambers, they explained volcanoes through stories. Many cultures believed that volcanoes were the homes or workshops of powerful beings. The ancient Greeks thought that the forge of Hephaestus, the blacksmith, was located beneath Mount Etna. In Hawaiian tradition, the volcano Kilauea is the home of Pele, the spirit of fire and volcanoes. These stories weren't just explanations for natural phenomena. They were ways of expressing respect and awe for the power of the earth. They were reminders that humans are small and that nature is vast. Even today, when we understand the science, there's still something mythical about volcanoes. They still inspire wonder. They still remind us that the earth is powerful, ancient, and beyond our complete control. Science has given us understanding, but it hasn't taken away the sense of mystery. Fact 73. Volcanic ash can travel incredible distances. When Mount St. Helens erupted in 1980, the ash cloud spread across the United States. Ash fell in cities more than 1,000 kilometers away. The ash was so fine that it caused problems for engines, clogged air filters, and made it difficult to breathe. People had to wear masks when they went outside. Roads were covered in a thick layer of grey powder. The sky turned dark in the middle of the day. It was like something from another world. But volcanic ash, despite being a nuisance and a hazard in the short term, has long-term benefits. As it breaks down, it enriches the soil. The regions affected by the Mount St. Helens eruption saw improved soil fertility in the years that followed. Farmers noticed better crop yields. The ash, which seemed like a disaster at first, became a gift over time. It's one of the many paradoxes of volcanoes. They disrupt and destroy, but they also nourish and create. Fact 74. Some of the most beautiful gemstones come from volcanic activity. Diamonds, for example, form deep in the Earth's mantle under extreme pressure and temperature. They're brought to the surface by volcanic eruptions, carried upward in a type of magma that travels very quickly. The volcanic rock that contains diamonds is called kimberlite, named after the town of Kimberley in South Africa, where many diamonds have been found. When kimberlite erupts, it forms narrow pipe-like structures that can extend deep into the earth. These pipes are mined for diamonds, and they're found in only a few places around the world. Each diamond is a piece of the deep earth, formed billions of years ago and delivered to the surface by volcanic fire. Wearing a diamond is, in a way, wearing a fragment of the planet's ancient interior, a crystal that has travelled through unimaginable heat and pressure to reach your hand. Fact 75. Volcanoes remind us of the Earth's immense age and the slowness of geological time. A mountain that seems eternal and unchanging is actually just a moment in the planet's story. The volcano might have taken 1,000,000 years to build, layer by layer, eruption by eruption. But in the context of Earth's 4.5 billion year history, 1,000,000 years is nothing. It's a blink. And yet to us, with our short lives, a volcano seems permanent. We see it as fixed, as solid, as something that has always been there and always will be. But the Earth knows better. The Earth knows that mountains rise and fall, that oceans open and close, that continents drift and collide. Volcanoes are part of that grand, slow dance. They're the Earth's way of staying alive, of releasing the heat and energy that build up inside. They're breathing, they're moving, and in their fire and their stone, they're telling a story that stretches back to the beginning of time and forward into a future we can barely imagine. Fact 76. There are volcanic regions where the ground itself is hot enough to cook food, and people have been using this natural heat for centuries in ways that connect them deeply to the Earth. In parts of Iceland, New Zealand, and Yellowstone, the volcanic heat that rises from deep underground creates opportunities that most of us can barely imagine. In Iceland, there's a traditional bread called rugbrauð that's baked by burying it in the ground near hot springs. The dough is placed in a pot, wrapped carefully in cloth, or placed in a special container, and then buried in a shallow hole where the geothermal heat slowly bakes it over many hours, sometimes overnight. When it's dug up the next morning, the bread is perfectly cooked, dark and sweet and dense, with a flavour that can't be replicated in a conventional oven. The process is slow and gentle, and the bread absorbs something from the earth itself, a mineral quality that people say makes it taste unlike any other bread in the world. In New Zealand, the Maori people have used geothermal heat for cooking for centuries, long before European settlers arrived. They prepare a feast called a hangi by placing food in baskets and lowering them into pools of boiling water heated by volcanic activity, or by burying them in pits where volcanic steam rises through the ground. The food cooks slowly over several hours, absorbing the flavours of the earth and the smoke, and the result is tender meat and vegetables with a unique taste that carries the essence of the land. It's a beautiful example of how people have learned to live alongside volcanoes, not just surviving the danger, but embracing the gifts that volcanic heat provides. The earth becomes more than just ground beneath your feet. It becomes a kitchen, a provider, a partner in daily life. This relationship between people and volcanic heat shows a deep understanding and respect for the planet's power, a willingness to work with nature rather than against it. Fact 77. Volcanic eruptions have created some of the most fertile farming regions in the world, and this extraordinary fertility has shaped entire civilizations and determined the course of human history in ways we often don't fully appreciate. The ancient Romans built their empire partly on the productivity of the land around Mount Vesuvius and the volcanic region of Campania. The volcanic soil there was so rich, so packed with nutrients, that farmers could grow multiple crops each year without depleting the land. Grapes, olives, wheat, and vegetables all flourished in the dark earth that was constantly being renewed by fine layers of volcanic ash settling from minor eruptions and weathering volcanic rock. The prosperity that came from this incredibly productive land helped fund Rome's armies, its magnificent architecture, its roads and aqueducts, its culture, and its expansion across the known world. The wealth generated by volcanic soil literally built an empire. Even today, more than 2,000 years later, the region around Naples, which sits in the shadow of Vesuvius, is known for its incredible food and agricultural products. The tomatoes grown there are famous worldwide, prized by chefs and home cooks alike for their intense flavour and perfect texture. The secret is the soil, enriched by thousands of years of volcanic ash and broken down volcanic rock. In Indonesia, the volcanic islands of Java and Bali support some of the densest populations on Earth, because the volcanic soil can sustain intensive agriculture year after year without exhausting itself. Rice paddies climb the sides of volcanic mountains in carefully terraced steps that have been maintained for generations. The same volcanoes that threaten these communities with eruptions also feed them, providing harvests that support millions of people. It's a relationship built on acceptance and gratitude, on understanding that the land gives generously, but also demands respect and careful stewardship. Farmers in these regions have learned over generations which crops grow best in volcanic soil, how to read the signs of the volcano's mood, and how to balance the rewards of living close to volcanic activity with the risks that come with it. Fact 78. There's a phenomenon called volcanic winter, and it can have devastating effects on human societies, reaching far beyond the immediate area of the eruption and affecting people thousands of kilometers away who may not even know a volcano has erupted. When a large volcanic eruption sends massive amounts of ash and sulfur dioxide into the stratosphere, these particles can remain suspended in the upper atmosphere for months or even years, circling the globe on high-altitude winds. The particles reflect sunlight back into space before it can warm the Earth's surface, causing temperatures to drop worldwide. Growing seasons shorten. Frost comes earlier in autumn and stays later in spring. Crops fail in regions that depend on predictable weather patterns. Famines spread as food becomes scarce and expensive. Historical records show that several major volcanic eruptions have coincided with periods of social upheaval, migration, conflict, and even the collapse of governments. The eruption of the Icelandic volcano Laki in 1783 caused crop failures across Europe and contributed to widespread hunger and economic hardship. Some historians believe this suffering and hardship helped set the stage for the French Revolution just a few years later, as desperate and angry people demanded change from governments that seemed unable or unwilling to help them. Even more dramatic was the eruption of a volcano called Semalis in Indonesia in 1257, one of the largest eruptions of the past 10,000 years. The ash and sulfur it released caused global cooling that lasted for several years, disrupting agriculture and causing hardship across multiple continents. Chronicles from Europe describe cold summers, failed harvests, and widespread suffering during this period. In some places, there are records of summer frosts and snow falling in July, crops freezing in the fields, and people struggling to find enough food to survive the winter. These volcanic winters remind us how interconnected our world is, how an eruption on one side of the planet can affect weather patterns, food supply, and human history everywhere else. They also remind us of our vulnerability to natural forces beyond our control. Fact 79. Mount Etna in Sicily has been erupting for thousands of years, with written records of its activity going back to ancient Greek and Roman times, and yet people continue to live on its slopes, building homes and farms and lives in the shadow of one of the world's most active volcanoes. Etna is almost constantly active in some form. Lava flows down its sides in rivers of glowing orange. Ash drifts over nearby towns, covering cars and streets in fine grey powder. The ground shakes with small earthquakes that rattle windows and knock pictures off walls, and still, the communities around Etna not only survive but thrive. The reason is simple and profound. The volcanic soil is incredibly fertile, perhaps the most productive agricultural land in all of Italy. Vineyards on the slopes of Etna produce excellent wine that's prized by connoisseurs around the world. The grapes grow in black volcanic soil that's rich in minerals, and winemakers say you can taste the volcano in the wine, a certain minerality and complexity that comes from the unique terroir. Citrus groves yield abundant fruit, with oranges and lemons that are sweet and flavourful. Olive trees grow strong and healthy, producing oil that's rich and golden. Vegetables grow large and tasty in gardens fertilised by volcanic ash. The people who live there have learned over generations to read the mountain, to understand its moods and its patterns. They know which types of activity are normal and which might signal something more serious. They know when to worry and when to simply watch the fireworks from a safe distance, when to evacuate and when to stay and protect their homes and animals. Etna is part of their identity, woven into their culture and their daily conversations. They don't live there in spite of the volcano. They live there because of it. The mountain has shaped their culture, their economy, their cuisine, their way of seeing the world and their place in it. There's a saying in Sicily that Etna is a generous mother and a severe teacher. She provides abundantly, giving fertile soil and spectacular beauty. But she also reminds people regularly that nature is powerful and unpredictable and beyond human control. Living with Etna requires humility, resilience, adaptability, and a deep respect for the earth and its processes. Fact 80. The island of Santorini in Greece is actually the remains of a massive volcanic eruption that happened around 3,600 years ago, during the Bronze Age, and the story of that eruption and its aftermath is one of the most dramatic chapters in human history. Before the eruption, Santorini was a single large island with a thriving civilization. Archaeological evidence shows that the island was home to an advanced society, with sophisticated architecture, beautiful frescoes and art, extensive trade networks reaching across the Mediterranean, and a level of prosperity that rivaled any culture of that time. The people built multi-story buildings with indoor plumbing, decorated their walls with elaborate paintings, and created pottery and tools that show remarkable skill and artistry. Then the volcano erupted in one of the most powerful explosions in human history, an event so massive that it's difficult to fully comprehend its scale. The centre of the island collapsed into the empty magma chamber far below, creating a huge caldera that immediately filled with seawater. What remained were the fragments of the island we see today, steep cliffs rising hundreds of metres above the water, surrounding a deep blue bay that marks where the heart of the island once stood. The eruption was so massive that it sent tsunamis racing across the Mediterranean Sea, waves tens of metres high that crashed into coastlines hundreds of kilometres away. Some researchers believe this eruption may have contributed to the decline of the Minoan civilization on nearby Crete, one of the most advanced cultures of the ancient world. The tsunamis would have destroyed coastal settlements and harbours. The ashfall would have buried farmland and poisoned water supplies. The disruption to trade routes would have been catastrophic. The ash from the eruption has been found in ice cores from Greenland, proof that the effects reached far beyond the local area and that material from the volcano travelled through the atmosphere to the far north. Today, Santorini is one of the most beautiful and romantic places in the World, a destination for travelers seeking stunning views and unforgettable sunsets. White buildings with blue domes cling to the cliffsides overlooking the caldera, creating a scene that's been photographed millions of times. Tourists come from all over to watch the sunset over the volcanic bay, to swim in the warm waters, to explore the archaeological sites. But beneath that beauty is a reminder of destruction, a scar left by one of the Earth's most violent outbursts, a place where an entire civilization was buried and lost for thousands of years. Fact 81. Volcanoes play a crucial role in the carbon cycle, which is the process by which carbon moves between the Earth's interior, the atmosphere, the oceans, and living things, and without volcanic activity, the Earth's climate would be very different from what we know today. When volcanoes erupt, they release carbon dioxide that has been stored deep in the Earth's mantle, sometimes for billions of years. This carbon was trapped in rocks and minerals, locked away from the surface, but volcanic activity brings it back into circulation. Over geological time, measured in millions and billions of years, this volcanic carbon dioxide has helped regulate the planet's climate and maintain conditions suitable for life. During periods when volcanic activity was high, such as when massive flood basalts covered huge areas of land, more carbon dioxide entered the atmosphere, trapping heat and warming the planet. During quieter periods, when volcanic activity decreased, carbon dioxide levels dropped and temperatures cooled. This natural cycle happens over timescales that are almost incomprehensible to us, much slower than the rapid human-caused changes we're seeing today. But it's an important part of how the Earth maintains a balance over the long term, how the planet regulates its own temperature and remains habitable. Volcanoes also interact with another part of the carbon cycle through a process called weathering. When volcanic rock is exposed to air and water, it slowly breaks down through chemical reactions. During this weathering process, the rock reacts with carbon dioxide in the air, pulling it out of the atmosphere and locking it into minerals that eventually wash into the ocean and settle on the seafloor. This process happens slowly but continuously over millions of years. Mountains created by volcanic activity eventually erode, and as they do, they help remove carbon dioxide from the air, acting as a natural thermostat for the planet. It's a slow dance between creation and destruction, between releasing carbon and capturing it, and volcanoes are at the center of this ancient rhythm that has kept Earth's climate relatively stable for billions of years. Fact 82. There are places where you can walk inside a dormant volcano and see the magma chamber where molten rock once pooled and churned, and visiting these places is like stepping into a cathedral built by the Earth itself. In Iceland, there's a volcano called Giga, and it's one of the only places in the world where visitors can take an elevator down into an empty magma chamber. The chamber is enormous, large enough to fit a cathedral or a small stadium inside. The walls are painted in shades of red, orange, yellow, and green from the minerals in the rock, creating a natural artwork that no human artist could duplicate. The colours shift and blend, with streaks and patterns that tell the story of how the magma moved and cooled. It's like stepping into the heart of the Earth, into a space that was once filled with glowing, molten stone churning at temperatures that would vaporize anything that touched it. The air is cool now, the rock is solid and stable, but you can still sense the power of what happened here, the tremendous forces that carved out this vast hollow space deep underground. Standing inside a magma chamber is a humbling experience that puts your own existence into perspective. You're surrounded by rock that was once liquid, that once flowed like water, but at temperatures of over 1,000 degrees. You're inside the engine room of the volcano, the place where the Earth's inner fire gathered and built pressure before bursting to the surface in an eruption. It's a rare and precious opportunity to witness geology from the inside, to see the structure that usually remains hidden beneath the mountain, inaccessible to everyone except through imagination and scientific instruments. Fact 83. Volcanic lightning is not fully understood, even though scientists have observed it many times and have captured stunning photographs and videos of this spectacular phenomenon. The leading theory is that during an explosive eruption, ash particles collide with each other at incredibly high speeds inside the eruption column, which can tower many kilometers into the sky. These violent collisions strip electrons from the particles, creating regions of positive and negative electrical charge. When the separation of charges becomes great enough, electricity arcs between them, creating lightning bolts that flash through the dark ash cloud. But there are still mysteries and aspects of volcanic lightning that don't quite fit the current theories. Sometimes volcanic lightning appears in patterns that don't quite match what we see in regular thunderstorms. Sometimes the lightning is more intense or more frequent than the theory predicts it should be. Some researchers think that ice particles forming in the eruption cloud might also play a role, similar to how lightning forms in regular storm clouds when ice crystals collide and create charge separation. Others suggest that the fragmentation of magma itself, the violent shattering of molten rock as it explodes into tiny pieces, might generate electrical charge through mechanisms we don't fully understand yet. Studying volcanic lightning is incredibly difficult because it requires being near an active, explosive eruption with the right equipment at exactly the right time, and obviously this puts researchers in considerable danger. But every observation, every photograph, every measurement brings scientists closer to understanding this spectacular phenomenon. Volcanic lightning is a reminder that eruptions are incredibly complex events, involving not just geology but also physics, chemistry, atmospheric science, and electrical phenomena. The volcano becomes a natural laboratory, a place where multiple forces and processes interact in ways we're still learning to decode and comprehend. Fact 84. Some volcanoes produce a type of volcanic glass called obsidian, and humans have prized this remarkable material for thousands of years, using it for tools, weapons, art, and trade. Obsidian forms when lava cools so quickly that crystals don't have time to grow and organize themselves into the regular patterns we see in most rocks. The result is a smooth, glassy rock that can be incredibly sharp when broken or chipped, sharper than even the finest steel blades produced by modern metallurgy. Ancient peoples discovered that obsidian could be chipped and flaked, using careful techniques to create tools with edges that were unbelievably sharp and useful for cutting, scraping, and piercing. Arrowheads, knives, scrapers, and other tools made from obsidian have been found at archaeological sites around the world. From the Americas to Africa to Europe to Asia, anywhere that volcanic activity created deposits of this valuable material. Obsidian was so valuable and so useful that it became a major trade item in the ancient world. People would travel hundreds of kilometers to obtain it, or they would trade other valuable goods like food, pottery, textiles, or metals to acquire obsidian tools and weapons. Archaeologists can trace ancient trade routes by analyzing obsidian artifacts and determining which volcanic source they came from, because each volcano produces obsidian with a unique chemical signature. In some cultures, obsidian was also used to make mirrors, jewelry, and ceremonial objects that had religious or spiritual significance. The Aztecs in Mexico used obsidian extensively, both for practical tools in daily life and for ritual purposes in their ceremonies. Even today, some surgeons use obsidian scalpel blades for certain delicate surgical procedures because the edge is sharper than steel and causes less tissue damage at the microscopic level, promoting faster healing. Obsidian is a gift from the volcano, a material born from fire and rapid cooling that has served humanity for millennia and continues to find uses even in our modern world. Fact 85. There are volcanoes that erupt with such tremendous force that they create sonic booms and sounds that can be heard halfway around the world. When the pressure inside a volcano is released suddenly during an explosive eruption, it can generate shock waves that travel through the air faster than the speed of sound, creating what's essentially a massive sonic boom. These shock waves create sounds that are almost beyond human comprehension in their intensity. The eruption of Krakatoa in Indonesia in 1883 produced some of the loudest sounds ever recorded in human history. The explosions were heard in Australia, more than 3,000 kilometers away, where people reported hearing what sounded like distant cannon fire or thunder. The sound was also heard in the island of Rodrigues near Mauritius, nearly 5,000 kilometers away, making it the most distant sound naturally heard by humans that we have records of. Closer to the volcano, the sound was so intense that it ruptured the eardrums of people and animals, and the pressure waves were powerful enough to crack walls and shatter windows. The shock waves from the eruption travelled around the entire world multiple times, detected by sensitive barometers in weather stations on the other side of the planet. Scientists tracked these pressure waves as they circled the Earth 7 times, before finally dissipating, becoming too weak to detect. Even more remarkably, the eruption created atmospheric pressure waves that altered weather patterns temporarily in distant locations. These sonic events demonstrate the sheer amount of energy released during a major volcanic eruption, energy that's difficult to comprehend in everyday terms. The sound is not just noise, it's the signature of a massive and sudden release of pressure that has been building for years or decades, a moment when the Earth literally roars with a voice that can be heard across oceans and continents. Fact 86. Volcanoes have influenced the development of entire industries and economic systems that continue to this day, providing materials and resources that are essential to modern life. The volcanic rock pumice, for example, is used in construction, horticulture, manufacturing, and even beauty products, making it a surprisingly versatile and valuable material. Pumice is so light and porous that it actually floats on water, which seems impossible for a rock, and yet it's also abrasive enough to smooth and polish surfaces effectively. It's used to make lightweight concrete blocks that are easier for workers to handle and provide excellent insulation for buildings, keeping homes cooler in summer and warmer in winter. It's added to potting soil and growing mediums to improve drainage and aeration for plants, helping roots breathe and preventing waterlogging that can kill delicate plants. Pumice is the key ingredient in many exfoliating scrubs and foot care products, used to remove dead skin and calluses gently but effectively. It's even used in industrial applications, in stonewashing jeans to give them a worn appearance, in polishing metals, and in filtering water. Pumice forms when lava that's extremely rich in gas cools rapidly, either in the air or when it hits water. As the lava cools, the gas bubbles are trapped throughout the rock, creating a structure that's full of tiny holes and cavities, giving it a texture like a sponge made of stone. Large deposits of pumice are found near many volcanoes around the world, and in some places pumice mining is an important part of the local economy, providing jobs and income for communities that live in volcanic regions. After major eruptions, vast fields of pumice can cover the landscape for kilometers in every direction, and over time, people harvest this material for various commercial uses. It's another example of how volcanic activity, while destructive and dangerous in the moment, provides resources that benefit human society long after the smoke has cleared and the lava has cooled. Fact 87. There are underwater volcanic eruptions that create floating islands of pumice that drift across entire oceans, carrying life with them and connecting distant ecosystems in ways that seem almost magical. When a submarine volcano erupts beneath the ocean surface and the lava is rich in gas, it can produce enormous amounts of pumice that float to the surface and drift on ocean currents. These pumice rafts can be truly enormous, sometimes covering hundreds of square kilometers, creating what looks like a solid mass of rock floating on the water. They can be so large and so densely packed that they've been known to damage ships that accidentally sail into them, clogging cooling systems and scratching hulls. These rafts can travel thousands of kilometers over months or even years before eventually sinking, as they become waterlogged or washing up on distant shores. In 2012, an underwater volcano near Tonga erupted and created a pumice raft that was estimated to be the size of Belgium at its largest extent. The raft drifted westward across the Pacific Ocean for months, slowly breaking apart and spreading out as it travelled. Eventually, pieces of it reached the coast of Australia, more than 5,000 kilometres from where the eruption occurred. Scientists who studied the raft made a fascinating discovery. The pumice wasn't travelling alone. It was carrying marine life with it, acting like a giant floating ecosystem. Algae, barnacles, corals and other organisms attached themselves to the pumice stones, hitching a ride across the ocean. When the pumice finally reached Australia and washed up on beaches, it brought species that wouldn't normally be able to travel such enormous distances on their own. Pumice rafts are like nature's own cargo ships, transporting life from one part of the ocean to another, connecting distant shores in unexpected ways, and potentially helping to repopulate damaged reefs or introduce new genetic diversity to isolated populations. It's yet another way that volcanic activity, even when it happens deep underwater where we can't see it, affects life across vast distances and contributes to the interconnected web of ecosystems that covers our planet. Fact 88. The study of ancient volcanic eruptions preserved in ice cores and sediment layers helps scientists understand Earth's climate history and provides crucial context for understanding the changes happening today. When a volcano erupts, the ash and sulfur dioxide it releases eventually settle in layers on the ground, in lake beds, on the ocean floor, and in glaciers. These layers can be preserved for thousands or even millions of years, creating a detailed record of past eruptions that scientists can read like pages in a history book. By drilling ice cores from glaciers in Greenland and Antarctica, researchers can extract long cylinders of ice that contain trapped bubbles of ancient air and thin layers of volcanic ash. These cores can extend down hundreds of meters, with each layer representing a different year, and by carefully analysing these layers, researchers can identify volcanic eruptions and date them precisely. Each layer tells a rich story if you know how to read it. It reveals when the eruption happened, how large it was, what kind of material was ejected, how long the ash remained in the atmosphere, and what kind of impact it had on global temperatures. By comparing these volcanic records with other climate data, such as tree rings that show growth patterns, ocean sediments that preserve the remains of microscopic organisms sensitive to temperature, and historical documents that describe weather and harvests, scientists can reconstruct in remarkable detail how volcanic eruptions have affected global temperatures and climate patterns over thousands of years. This research has shown that major eruptions have triggered cooling periods throughout history, sometimes lasting several years and causing widespread disruption to agriculture and human societies. Understanding these past events helps scientists predict what might happen if a large eruption occurs in the future, allowing better preparation and response planning. It also provides essential context for understanding natural climate variability and how it differs from the rapid, unprecedented changes caused by human activities today, particularly the burning of fossil fuels and the release of greenhouse gases. Fact 89. Mount Kilimanjaro in Tanzania is a volcanic mountain with 3 distinct volcanic cones, though it's far more famous for being the highest peak in Africa and a destination for adventurous climbers than for its volcanic nature. Kilimanjaro is actually made up of 3 separate volcanic cones that formed at different times and have different histories. 2 of them, Mawenzi and Shira, are extinct, meaning they will never erupt again because the geological conditions that created them have changed and there's no longer a source of magma to feed them. But the 3rd cone, called Kibo, is technically dormant rather than extinct, which means it could potentially erupt again someday, though there are currently no signs of activity and scientists don't expect an eruption in the foreseeable future. The last major eruption of Kilimanjaro was more than 300,000 years ago, long before modern humans existed. Since then, the mountain has been shaped more by erosion, weathering, and the advance and retreat of glaciers than by volcanic activity. Kilimanjaro is famous around the world for its distinctive snow-capped summit, which rises nearly 6,000 meters above sea level, creating a stunning contrast between the tropical heat at the base, where elephants and other African wildlife roam through forests and grasslands, and the ice and snow at the top, where temperatures drop far below freezing. Climbing Kilimanjaro takes most people 5 to 7 days, ascending through multiple climate zones from tropical forest to alpine desert to Arctic conditions at the summit. However, the glaciers on Kilimanjaro that have existed for thousands of years have been shrinking rapidly in recent decades due to climate change and changing weather patterns. Scientists predict that the ice could disappear entirely within the next few decades if current trends continue. When that happens, Kilimanjaro will lose one of its most iconic and distinctive features, the gleaming white cap that's visible for hundreds of kilometers across the African plains. It's a sobering reminder that even mountains that seem eternal and unchanging are vulnerable to the rapid changes happening in our world today, and that the landscapes we take for granted may not be there for future generations to experience. Fact 90. There's a volcanic region in the western United States called the Cascade Range, stretching from northern California through Oregon and Washington into British Columbia in Canada, and this mountain range includes some of the most famous and potentially dangerous volcanoes in North America. The Cascades include iconic peaks like Mount St. Helens, which erupted catastrophically in 1980, Mount Rainier, which towers majestically over the Seattle area, Mount Shasta, Mount Hood, and many others. These volcanoes are all part of the Ring of Fire, formed by the subduction of the Juan de Fuca tectonic plate beneath the North American plate. As the oceanic plate descends into the hot mantle, it melts and generates magma that rises to feed the volcanic chain. All of these volcanoes are considered potentially active, meaning they could erupt again, though they erupt infrequently, sometimes with centuries between events. Mount Rainier, which dominates the skyline of Seattle and Tacoma and is visible from both cities on clear days, is considered one of the most dangerous volcanoes in the United States, not necessarily because it's more likely to erupt than others, but because of its proximity to large populations, and because it's covered with massive glaciers. If Mount Rainier were to erupt, the heat from the eruption could rapidly melt enormous amounts of ice and snow, creating massive lahars, those deadly rivers of mud and debris that would rush down the valleys at high speed toward populated areas where hundreds of thousands of people live. Emergency plans are in place, evacuation routes have been established, and scientists monitor the mountain constantly for any signs of unrest, measuring earthquake activity, ground deformation, gas emissions, and any other indicators that might suggest magma is moving beneath the surface. But the presence of these magnificent volcanoes in the Cascade Range is also a reminder of the beauty and power of the natural world. These mountains dominate the landscape, their snow-covered peaks visible from far away on clear days, standing as silent sentinels over the region, beautiful and dangerous at the same time. Fact 91. Volcanoes can create their own localized weather systems, not just through the massive ash clouds that block sunlight, but also through the sheer amount of heat they release into the atmosphere during eruptions. During the eruption of Kilauea in Hawaii in 2018, which was one of the most significant and destructive eruptions in recent decades, the lava flows were so extensive and so incredibly hot that they created noticeable localized wind patterns and weather effects. The tremendous heat rising from the flowing lava caused air to rise rapidly through convection, creating a low-pressure area directly above the lava. This pulled in cooler air from the surrounding areas, creating swirling winds around the lava flows and generating what were essentially miniature weather systems centered on the volcano itself. These volcanic winds carried volcanic gases, primarily sulfur dioxide, and tiny fragments of volcanic glass called Pele's hair, named after the Hawaiian spirit associated with volcanoes and fire. Pele's hair forms when lava is thrown into the air by fountaining, or is blown by strong winds, and the molten rock is stretched by the wind into thin, delicate strands that look remarkably like golden or brown hair. These strands can be carried many kilometers on the wind before settling on the ground, draping over trees and fences and collecting in sheltered areas. They're beautiful to look at, but also sharp and brittle, like spun glass, and they can irritate skin, eyes, and lungs if you come into contact with them. The interaction between volcanic heat and the surrounding atmosphere is complex, and creates phenomena that scientists are still studying and trying to understand fully. Every eruption teaches researchers something new about how volcanoes influence not just the solid ground, but also the air, the weather patterns, and the entire environment around them. The volcano becomes a force that affects every aspect of the landscape, from the rocks beneath to the sky above. Fact 92. Some of the earliest known human art depicts volcanoes, suggesting that our ancestors were both fascinated and awed by these powerful natural features. In Turkey, there's an ancient settlement called Çatalhöyük that dates back more than 9,000 years, making it one of the oldest known towns in the world. On the walls of some buildings excavated at this site, archaeologists found murals and paintings that appear to show a nearby volcanic mountain erupting. One particularly famous mural shows what looks like a settlement or town in the foreground, with rectangular shapes representing houses, and behind it rises a mountain with dots and patterns spreading outward from its peak, which many researchers interpret as representing an eruption or flowing lava. If this interpretation is correct, and most experts believe it is, this would be one of the oldest known landscape paintings in human history, and possibly the earliest depiction of a volcanic eruption ever created. The volcano in question is likely Hasan Dag, a volcanic mountain located relatively near the ancient settlement, and geological evidence shows it was active during the period when people lived at Çatalhöyük. The painting suggests that the people who lived there witnessed eruptions firsthand and considered them significant enough to record on their walls, making them part of the permanent decoration of their homes. This ancient artwork creates a powerful connection across thousands of years, a direct link between us and our distant ancestors who watched the same natural forces we still observe today. It's a reminder that humans have always been witnesses to volcanic activity, and we've always tried to understand it, to capture it, to make sense of the Earth's immense power through art, story, symbol, and eventually through science. The impulse to document and understand volcanoes is ancient and universal, part of what makes us human. Fact 93. Volcanic eruptions can create temporary islands that emerge from the ocean, and then disappear almost as quickly as they formed, existing for just a brief moment in geological time. In the ocean, when an underwater volcano erupts near the surface, it can build up enough material through repeated eruptions to break through the water and create a new island where none existed before. But if the material is primarily loose ash and cinders rather than solid, welded lava, the waves and currents quickly erode it away, and the island vanishes back beneath the surface. In 2013, a volcano erupted near the coast of Japan in the Pacific Ocean and created a brand new island virtually overnight. At first, scientists thought it might be temporary, just another fleeting volcanic island that would be washed away by storms within months. But then the eruption continued for weeks and months, producing more solid lava that welded the loose material together and stabilized the structure. The island grew larger and eventually merged with a nearby older island called Nishinoshima, dramatically expanding the coastline and creating new land that continues to exist today. In other cases around the world, volcanic islands have formed and then vanished within months or even weeks, washed away by powerful storms and relentless ocean currents before they could stabilize. These temporary islands are fascinating reminders of the constant negotiation and battle between land and sea, between the constructive forces that build and create and the destructive forces that wear away and erode. The Earth builds through volcanic activity, and the ocean erodes and reclaims, and the boundary between them is always shifting, always in motion, never fixed or permanent. These fleeting islands also remind us that the Earth's surface is not static and unchanging, as it appears in our short human lifetimes, but is actually dynamic and constantly being reshaped by forces both beneath and above the surface. Fact 94. There are places around the world where volcanic heat is used to generate electricity on a large scale, providing clean, renewable energy that doesn't produce greenhouse gases or air pollution. In countries like Iceland, the Philippines, Kenya, New Zealand, and parts of the western United States, geothermal power plants tap into the enormous heat stored in volcanic regions deep underground. Engineers drill wells deep into the ground, sometimes several kilometers down, where temperatures are extremely high due to proximity to magma chambers or to rocks heated by volcanic activity. Water is pumped down through some wells, where it's heated to extremely high temperatures by the surrounding rock, and returns to the surface through other wells as steam or superheated water. The steam is used to drive turbines connected to generators that produce electricity, similar to how conventional power plants work, but without burning any fuel. Geothermal energy is incredibly reliable and consistent because, unlike solar or wind power, it doesn't depend on weather conditions or time of day. The heat from the Earth is essentially constant, available 24 hours a day, every day of the year, providing what's called baseload power. Geothermal plants can operate continuously without interruption, providing steady, predictable power to the electrical grid. In Iceland, geothermal energy provides about a quarter of the country's electricity and nearly all of its heating for homes and buildings. Homes are warmed by hot water piped directly from geothermal wells, eliminating the need for furnaces or heaters. Even the sidewalks in Reykjavik, the capital city, are heated in winter using geothermal water, melting snow and ice automatically and making walking safer and more comfortable. It's an elegant and efficient solution, using the Earth's own heat to make life more comfortable and sustainable. Volcanic regions, often seen as dangerous or inhospitable places to live, become valuable sources of clean energy and economic prosperity when approached with ingenuity, respect, and careful engineering. Fact 95. The chemical composition and quantities of volcanic gases provide crucial clues about what's happening deep inside a volcano, and monitoring these gases has become one of the most important tools for predicting eruptions and keeping communities safe. By measuring these types and amounts of gases being released from volcanic vents, fumaroles, and the ground itself, scientists can infer important information about the depth and temperature of the magma, how much pressure is building in the system, and whether an eruption might be approaching. Sulfur dioxide is one of the most important gases to monitor because it comes directly from magma. An increase in sulfur dioxide emissions often indicates that fresh magma is rising from great depth, bringing sulfur-rich gases with it as it ascends. This can be an early warning sign that the volcano is becoming more active. Carbon dioxide is another key gas that scientists watch carefully. It can escape from magma even when the magma is very deep underground, much deeper than sulfur dioxide can escape from, so changes in carbon dioxide levels can sometimes be detected before other warning signs appear, providing even earlier warnings of potential activity. Scientists use a variety of sophisticated instruments to measure these gases, including spectrometers that can detect gases from a distance by analyzing the light passing through volcanic plumes, and direct sampling instruments that collect gas samples for detailed laboratory analysis. Sometimes researchers fly drones or helicopters directly over active craters to collect samples, a dangerous but necessary task. In other cases, permanent monitoring stations are installed on the volcano, sending data continuously in real time to observatory computers, where scientists can track changes minute by minute. This work is a critical part of volcano monitoring systems that exist around the world to protect communities living near active volcanoes. By understanding the invisible chemical signals that the volcano sends out, scientists can issue warnings days or weeks before an eruption, giving people precious time to evacuate, protect property, and prepare for what's coming. It's detective work at the highest level, reading subtle signals and interpreting the complex language of the Earth. Fact 96. Some volcanic eruptions are so cold that they don't involve molten rock at all, and these strange phenomena have completely changed our understanding of what volcanism can be and where it can occur in our solar system. These are called cryovolcanoes, or ice volcanoes, and they exist on some of the moons orbiting the giant planets in the outer reaches of our solar system. Places so cold and so distant from the sun that water ice is as hard as granite and behaves like rock on Earth. Instead of erupting molten lava made of silicate minerals, cryovolcanoes erupt water, ammonia, methane, or other substances that are liquid or slushy in the extremely cold conditions of the outer solar system, where temperatures can drop to -200 degrees Celsius or even colder. When these materials reach the surface and are exposed to the vacuum of space, or the thin atmospheres of these distant moons, they freeze almost instantly, building up icy mountains, flows, and deposits that look remarkably similar to volcanic features on Earth, just made of completely different materials. Enceladus, a small moon of Saturn that's only about 500 kilometers in diameter, has dramatic geysers that spray water ice and vapor into space from long cracks in its icy crust called tiger stripes. These geysers shoot plumes of ice particles hundreds of kilometers into space at speeds of several hundred meters per second. Scientists believe there's a liquid ocean of water beneath the thick ice shell covering Enceladus, kept liquid and warm by tidal forces from Saturn's powerful gravity, which constantly squeezes and flexes the moon as it orbits. The geysers are essentially ice volcanoes, releasing material from this hidden ocean and creating spectacular plumes that are visible from spacecraft. Some of this ejected material falls back to the surface like snow, covering Enceladus in a layer of fresh, bright ice that makes it one of the most reflective objects in the solar system. But some of the material escapes the moon's weak gravity entirely and becomes part of Saturn's magnificent ring system, specifically the E-ring, which is made almost entirely of ice particles from Enceladus. The discovery of cryovolcanism has completely expanded our understanding of what volcanism can be. It's not just about extreme heat and fire and molten rock. It's fundamentally about pressure and the movement of materials from the interior of a world to its exterior, about the restless nature of planets, moons, and other bodies, whether they're rocky like Earth or icy like the moons of the outer solar system. This discovery has profound implications for the search for life beyond Earth, because the liquid water oceans beneath these icy moons, kept warm by tidal heating and connected to the surface by cryovolcanic activity, might provide habitable environments where life could potentially exist, even in the cold, dark outer reaches of our solar system. Fact 97. Volcanic craters sometimes become important ecosystems and biodiversity hotspots, transforming over centuries from barren, lifeless scars into thriving communities of plants and animals found nowhere else on Earth. When a volcanic crater is no longer active and hasn't erupted for a long time, it begins to fill with rainwater, snowmelt and runoff from the surrounding landscape, gradually creating a lake that can become quite deep. The steep walls of the crater provide shelter from wind and weather, creating a unique microclimate inside that can be quite different from the surrounding area. The water that collects at the bottom becomes a focal point for life, a precious resource in what might otherwise be a harsh volcanic landscape. Over time, measured in decades and centuries, plants begin to colonize the slopes of the crater. Seeds arrive on the wind, carried by birds or transported by animals. Mosses and lichens are often the first to establish themselves, growing slowly on the bare volcanic rock and beginning the long process of breaking it down into soil. Eventually grasses and shrubs take root, then trees if the climate permits. Insects arrive, followed by spiders and other invertebrates. Birds discover the crater lake and begin to nest in the vegetation growing on the slopes. Mammals come to drink from the water. Fish might colonize the lake if there's a connection to streams or rivers, or sometimes fish eggs are carried in by birds on their feet or feathers. Some crater lakes become incredibly rich in life because of the minerals dissolved in the water from the volcanic rock, providing nutrients that support abundant growth of algae and aquatic plants, which in turn support fish and other animals. In East Africa, along the Great Rift Valley where volcanic activity is common, there are several crater lakes formed by extinct volcanoes, and these lakes are home to unique species of fish, particularly cichlids, that evolved in isolation within each crater lake. Because each lake is separated from the others and from river systems, the fish in each crater evolved independently, developing unique colours, behaviours, and adaptations found nowhere else. These crater lakes have become natural laboratories for studying evolution and speciation. In Costa Rica, volcanic craters have become lush cloud forests, perpetually shrouded in mist and fog, filled with incredible biodiversity including rare orchids, colourful birds, monkeys, and countless insect species. The very feature that was once a source of tremendous destruction and death becomes, given enough time and patience, a cradle of life and diversity. It's a transformation that speaks powerfully to the resilience and adaptability of nature, to the way life finds opportunities and establishes itself even in the most unlikely and challenging places, turning scars into gardens over the long arc of time. Fact 98. Volcanic islands in the middle of the ocean, far from any continent, are some of the most remote and isolated places on Earth, and they provide natural laboratories for studying evolution, ecology, and how life colonizes new territory and adapts to challenging environments. Because these islands are separated from continents by hundreds or thousands of kilometers of open ocean, the species that live there must either arrive by extraordinary means or evolve from the few successful colonizers that manage to reach the islands against tremendous odds. This geographic isolation leads to unique evolutionary paths and the development of species found nowhere else on Earth, species that evolved in isolation over millions of years. In the Hawaiian Islands, which are more than 3,000 kilometers from the nearest continent, there are species of birds called honeycreepers that provide one of the most remarkable examples of evolution ever documented. These birds, which now include more than 50 different species, all evolved from a single ancestral species that arrived in Hawaii several million years ago, probably blown off course during a storm. Over time, as this founding population spread to different islands and different habitats within the islands, they diversified into many different species through a process called adaptive radiation. Each species adapted to exploit different food sources and occupy different ecological niches. Some honeycreepers evolved short, strong beaks, perfect for cracking seeds and nuts. Others developed long, curved beaks for sipping nectar from flowers. Still others have beaks adapted for catching insects or probing bark for grubs. The diversity of beak shapes and sizes among Hawaiian honeycreepers rivals that of Darwin's famous finches in the Galapagos, and the variety of colours, songs and behaviours is equally impressive. This process of adaptive radiation, where a single ancestral species gives rise to many diverse descendants, is one of the key mechanisms driving the diversity of life on Earth, and volcanic islands provide perfect conditions for it to occur. The isolation means there are fewer predators and competitors from the mainland. The variety of habitats on a single island, from coastal areas to mountain forests to high-altitude scrubland, provides many different ecological niches to fill, and the lack of established species means newcomers have opportunities to adapt and specialize without intense competition. Studying these islands and their unique inhabitants helps scientists understand fundamental questions about how life diversifies and adapts over time, how new species arise, how ecosystems develop and change, and what factors make some species successful while others go extinct. The insights gained from studying volcanic islands have shaped our entire understanding of evolution and continue to inform conservation efforts worldwide. Fact 99. The sound of a volcano can be strangely calming and even meditative, even though the forces at work are anything but calm, and this paradox reveals something interesting about how humans relate to powerful natural phenomena. In Hawaii, where eruptions are relatively gentle and frequent compared to explosive stratovolcanoes, people sometimes gather in designated safe areas to watch lava flows at night, and they describe the experience as peaceful and even spiritual despite the obvious power on display. The sound of flowing lava is a constant low rumble, deep and resonant, that you feel in your chest as much as hear with your ears. It's punctuated by occasional sharp cracks and hisses as lava breaks through cooled crust that has formed on its surface, or as pockets of trapped gas escape violently, or as lava meets water and flashes instantly to steam. There's a rhythm to these sounds, an almost musical quality, like the earth itself has a heartbeat that you can hear and feel. Some people describe it as profoundly soothing. This reminder that the earth is alive and active and powerful. The glow of the lava against the dark night sky creates an orange and red light that flickers and dances, illuminating the rising steam and smoke. The warmth radiating from the flow can be felt from dozens of meters away, a physical presence that reminds you of the incredible heat contained in the molten rock. The combination of sound, light, heat, and the knowledge that you're witnessing creation in real time, watching new land being born, creates an experience that many people describe as transformative and moving. It's a reminder that not all manifestations of power need to be violent or frightening. Sometimes power is steady, patient, unstoppable, but not aggressive. The lava flows slowly, usually no faster than a walking pace, but it never stops, never hesitates, never turns back. It shapes the land inch by inch, meter by meter, creating new ground that will someday support forests and farms and homes and lives. Watching a volcano in a relatively safe setting like this is like watching time itself unfold, seeing the Earth at work on the timescales it operates on, reshaping and renewing the surface of the planet. It puts human concerns and timescales into perspective, reminding us that we are temporary visitors on a planet that existed long before us, and will continue long after we're gone. A planet that's still actively creating itself, still writing its story in fire and stone. Fact 100: volcanoes connect us to the deep history of our planet and to the universe beyond in ways that are both scientific and philosophical, reminding us of our place in an ancient and ongoing story. Every atom in your body, except for hydrogen, which was created in the Big Bang, was forged inside a star through nuclear fusion and scattered across space when that star exploded in a supernova. Those atoms, including the carbon in your DNA, the iron in your blood, the calcium in your bones, the oxygen you breathe with every breath, all of it drifted through the cosmos for billions of years until gravity gathered them together to form our solar system, our planet, and eventually you. Volcanoes bring material from deep inside the Earth to the surface, material that's been hidden and cycling through the planet's interior for billions of years since the Earth first formed. When you stand near a volcano, when you touch volcanic rock still warm from its journey to the surface, you're touching something that connects you directly to the deep past and the deep interior of the planet. You're witnessing a process that has been happening since the Earth was young, since it was a molten ball slowly cooling and differentiating into layers. The iron in your blood and the iron in volcanic rock came from the same stellar source. The oxygen you breathe was released by volcanic activity over billions of years, helping to create the atmosphere that makes life possible. You are literally made of the same stuff as volcanoes, made of stardust and ancient stone, made of atoms forged in stellar furnaces and cycled through the earth by volcanic processes. And in that realization, there's a kind of peace and perspective. You are part of something vast and ancient and ongoing. You belong to this planet, to this universe, to this story that's still being written with every eruption, every breath, every heartbeat. You are connected to the beginning of time and to the distant future, connected to every other living thing, connected to the rocks beneath your feet and the stars above your head. Volcanoes remind us that the Earth is not a dead ball of rock hurtling through space, but a living, breathing, dynamic world that's constantly changing and renewing itself. They remind us that creation and destruction are not opposites, but partners in an endless dance. They remind us that from destruction comes new life, that from fire comes fertile soil, that from chaos comes order and beauty. Standing in the presence of a volcano, whether it's sleeping peacefully or actively erupting, is an experience that transcends simple observation and becomes something deeper, something that touches the very core of what it means to be human and alive on this remarkable planet we call home.